Hello everyone, my name is Rami Sugumaran. My matrix card number is 01DE24F1122. Today, my partner and I will be discussing about the environmental control coal-fired steam power plant. Let's dive into it. Okay, now let's talk about the introduction. A coal-fired power plant is a large industrial facility that generates electricity by burning coal as its primary fuel source. The process begins with the combustion of crushed or pulverized coal in a boiler, where the heat energy produced is used to convert water into high-pressure steam. This steam is then directed toward a turbine, causing it to rotate and drive an electrical generator, which produces electricity for residential, industrial, and commercial use. Coal-fired power plants have long been a backbone of many national power systems because they can provide a stable, continuous, and large-scale energy supply. However, this method of power generation has several environmental drawbacks. The burning of coal releases pollutants such as carbon dioxide (CO2), sulfur dioxide which is SO2, and nitrogen oxide, and fine particulate matter, all of which contributes to air pollution, acid rain, and global warming. Additionally, the process produces a large amount of ash and requires significant amount of water for cooling, leading to potential water and soil contamination. Therefore, while coal-fired power plants remain essential for meeting energy demands, it is increasingly important to apply sustainable technologies and environmental control systems to minimize their impact and move toward cleaner, more efficient power generation. So for the day, we have three questions to be discussed, and I'm going to answer the first question, which is propose suitable method environmental control strategies for the components responsible for pollution. As you can see, this is my slide of answer. In a coal-fired power plant, pollution mainly comes from three sources, which is the emission stack, ash disposal system, and cooling water system. To control these pollutants, several environmental strategies can be applied. For the emission stack, electrostatic precipitator, also known as ESP, is used to remove fine dust and ash particles from the flue gas before it is released to the atmosphere. Next, a wet scrubber, also known as a flue gas desulfurization system, is installed after the ESP to remove harmful gases such as sulfur dioxide and nitrogen dioxide. The scrubber also uses a limestone and water mixture that reacts chemically with these gases to neutralize them before release. For the ash disposal system, a dry ash handling method is recommended. Instead of mixing ash with water, the dry ash is collected and stored in silos, preventing contamination of soil or groundwater. This dry ash can also be used for manufacturing cement or bricks, promoting the waste minimization. For the cooling system, a closed-loop cooling tower is proposed. This system recycles the same water repeatedly instead of discharging it into nearby rivers or lakes. It significantly reduces water consumption and prevents thermal pollution that can harm aquatic life. Now, the next slide which is my block diagram. As you can see, there's a coal, boiler, emission stack, also known as ASP, steam turbine, ash handling, generator, condenser, and cooling tower. Let me briefly explain about it. Okay, this is the block diagram of a coal-fired steam power plant. The process starts with coal, which is crushed into powder and burned in the boiler to produce heat. This heat converts water into pressure steam, which then drives the steam turbine. As the turbine blades rotate, mechanical energy is produced and transferred to the generator, where it's converted into electrical energy through electromagnetic induction. The exhaust steam from the turbine moves into the condenser, where it's cooled back into water and reused in the boiler to maintain a continuous cycle. The hot cooling water then is cooled down in the cooling tower before recirculation. Meanwhile, the electrostatic precipitator removes dust and ash from flue gases before releasing them through the emission stack, helping reduce pollution. The ash handling system collects and disposes of the remaining ash safely. Overall, this plant converts the chemical energy of coal into electricity efficiently while maintaining environmental control through immersion and ash handling system.
Good day to all. My name is Thomas and my metric card number is 01DE24F1107. So as you can see here, for question 2, compare differences between two environmental filtering methods. As you can see at our slide here, we have the differences. Starting from the type of pollutant removed. So for the electrostatic precipitator or ESP, it removes solid particles such as dust and ash. And for the wet scrubber, it removes gaseous pollutants. Another one of the differences is the working principle. So the working principle for ESP is electrical charging and collection, while the wet scrubber uses chemical absorption with liquid. Then we have operating costs. The operating cost for ESP is low, while the operating cost for wet scrubber is high because it uses water and chemicals. And another one of the differences is environmental impact. So for the ESP, it produces reusable dry waste, while for the wet scrubber, it produces liquid waste. Move on to the third and final question. Relate the proposed solutions to SDG 7 by explaining how they contribute to affordable and clean energy goals. You see again in the slide here. The proposed environmental control system, such as electrostatic precipitator, ESP, and wet scrubber, strongly supports Sustainable Development Goal 7, affordable and clean energy, which aims to provide reliable, sustainable, and modern energy while reducing environmental impact. Coal-fired power plants remain a major electricity source, but produce pollutants like CO2, SO2, and NO, and dust particles. By adopting modern control technologies, coal-based energy can become cleaner and more efficient, helping nations meet power demands responsibly. The ESP captures almost all dust and fly ash from exhaust gases, preventing harmful emissions and improving air quality. The wet scrubber removes gases such as SO2 and X, reducing acid rain and protecting ecosystems. Cleaner combustion also improves boiler and turbine efficiency, requiring less coal to produce the same amount of electricity and lowering CO2 emissions. Thus, these systems support SDG Target 7.2, Cleaner Energy System, and Target 7.3, Energy Efficiency, enabling more sustainable and environmentally responsible power generation. So from this slide, we can say a coal-fired power plant remains one of the major sources of electricity generation today, but it also brings serious environmental challenges. Through the use of modern control technologies such as electrostatic precipitators, ESP, and wet scrubber system, we can significantly reduce harmful emissions, making power generation much cleaner and more sustainable. These methods not only minimize air pollution and protect ecosystems, but also improve the efficiency of energy production. By applying these technologies, we take an important step towards achieving Sustainable Development Goal 7, affordable and clean energy, which aims to ensure access to reliable and environmentally responsible power for all. This project highlights that with the right innovation and awareness, even traditional energy sources like coal can move toward a more sustainable and cleaner future. Thank you.